In today's lecture, we are going to discuss about the timers of PIC16F877. Timers are used to measure the time or generate an accurate time delay. Timer is a simple binary counter that can be configured to count clock pulses. Once if it reaches the maximum value, it will roll back to 0, setting up an overflow flag and generates the interrupt if enabled. Can't a microcontroller do this action? The counting can also be done by microcontroller, but when the microcontroller start doing this counting, then the efficiency of the other tasks done by microcontroller reduces. What are the different types of timers? There are three types of timers: timer 0, timer 1, and timer 2. Out of this, timer 0 is an 8-bit timer. Timer 2 is a 8-bit timer. Timer 1 is a 16-bit timer. When the number of bits increases, the resolution obviously increases. All timers can act as timer or a counter or PWM generation. This has a prescaler block which is inside the timer module, which is used to divide the clock frequency by a constant. It allows the timer to be clocked at the rate a user desires. Timer interrupt: as the timer increments and when it reaches its maximum value of 255 or 65536, it will trigger an interrupt and initialize itself to 0 back again. This interrupt is called timer interrupt. Then frequency of oscillator. It is the frequency of the crystal used. The time taken for the timer register depends on the value of prescaler and the value of the oscillator frequency. Timer 0. The features of timer 0 are: it is an 8-bit timer. It's readable and writable. It has internal or external clock set. Edge selection for external clock is done. Interrupt and overflow is done. If you see the registers in timer 0, there are three types of registers in timer 0. One is the option register, second is timer 0 TMR 0 register, and third is INTCON register. So option register is an 8-bit register, right? So here out of these 8-bit, the LSB 3 bits is used to select the prescaler value, prescaler bits. So based whether it is a watchdog timer, it is act as a timer, whatever be is, what will be the clock. So this is prescaler assignment bit, which is used to assign whether it is a watchdog timer or a timer 0. TMR 0 source edge select bit. Increment on high to low transition on T0 clock P0. Increment on low to high transition on T0 clock. Then timer 0 CS clock source select bit. Then this is interrupt edge select bit. And this is port B pull up enable register. These are the 8 bits of option register. Then we have the interrupt control register. In the interrupt control register, again it's an 8-bit register. The 7th bit is the global interrupt enable bit. 6th bit is the peripheral interrupt enable bit. Then timer 0 overflow interrupt enable bit. Then we have the interrupt enable bits. Then we have port change interrupt enable bit. Then timer 0 overflow interrupt flag bit. And then INTF and RBIF, which is not used for timers. Flags are used. So these are the 8 bits of the interrupt control register. TMR 0 register. This is the 8-bit register that holds the timer values. So since it is 8-bit, it counts from 0 to 255. And this is how a delay is calculated. Suppose if I want to count for 1 second, then with the prescaler value of 256, how the delay is calculated for counting is mentioned here. So this is the frequency which is used, and timer 0 code is used. So here time is 0. See the port registers initialized. Then the timer registers like option registers are initialized. Then see this is used to make the LED on and off, that is blinking. And this is used for delay purpose. That is to count the here it is been mentioned to count 42. That is for 1 second it will be blinking. So this is for the assessment and references, and thank you.